Hello and welcome everybody to this month's Public Global R&D. We have an exciting agenda today. First off, let me introduce myself. My name is David and I'm in the message routing team here at DFINITY. And with that, let's directly start with updates, and in particular with Kyle, who is giving us an update on metrics.
Yeah, thank you, David. Appreciate it. So I'm going to do a CK token specific update. Here's some data on what's been going on in 2024 specifically. So with ckUSDC launching 6 days ago, Thursday of last week, here's just some quick stats. Over $250,000 has been minted. Of that, we have over $400,000 that's been transferred. It's actually kind of interesting. The weekend was pretty, was a lull in activity, but then, so Thursday, Friday was, had some activity, and now Monday, Tuesday has been picking back up. So it definitely seems to be some day of the week trend happening there. And then over 400 unique sender addresses. So a decent start for ckUSDC, and hopefully we continue to see those numbers go higher. Let's move on to ckETH. So this data right here is specific to 2024. And in addition to that, there were 2 different dusting events that created tens of thousands of transactions earlier in January. Those are removed from here. So you have 6.7 thousand ckETH transferred this year alone. And of that, there's been over 4,500 unique senders. So that's, what is that, about $20 million in ckETH transfers throughout this year. And then this chart you see down at the bottom is the number of transactions per day. And again, you just kind of see a nice slight up and to the right trend going on, followed by what you might call like an explosion in transactions over the last few days that have occurred since the Tritium go live. So I think that that's probably a good sign of USDC and ckETH being used together. So maybe in a month or two, I'll come back and present some new data that hopefully confirms that that is the new trend, and we can continue to see up and to the right. And then finally, let's touch on ckBTC. So here we have a little over 1,800 Bitcoin worth of ckBTC transferred in 2024. I think that's a little over $120 million, though I shouldn't do public math, so that could be bad. Interestingly, there's been 52,000 unique senders. Now, I don't think that means that there's 52,000 people who are interacting with Bitcoin. I think some of this is driven by ordinal activity, because whenever there's a trade, that typically generates a new wallet, ckBTC. But still, nice to see that traction. And then again, just like I did for ckETH, here's the number of transactions per day. This time I had to do it on a log scale, which is always a good sign when you're moving to a log scale. And you can see steady growth throughout the year. The 2 spikes you see in April and May actually relate to the Motoko Sentinels ordinal launch and the Journey to Chain Fusion launch last week. So ordinals are actually a very good way to drive ckBTC transactions in transaction numbers. Feel free to answer any questions in the chat. Thanks.
Thanks a lot. Nice to see the CK tokens flow. Next up is an update on developer experience by Jason.
Thanks, David. Hi, everybody. I'm Jason, part of the SDK and languages teams. Today, I'm going to give you an update on how we're doing in terms of developer experience. As you're probably aware, this is a very important subject to DFINITY's R&D, and it's one of the milestones we published on our recent roadmap. And so part of our commitment to DX is giving you regular updates as we progress. So to recap, since our last update, which was in March, we've shipped 2 new DX-related features and scheduled work for 1. 8 new topics were created on the feedback board, and 1 topic was closed. So let's take a look at some of the highlights. Next slide, please. So we shipped this evict mode feature, which basically means that when WASM code is installed onto a canister, the pre-upgrade hook can be skipped. And this is useful for both testing and disaster recovery. Next slide, please. Canister logging was shipped, and this makes it possible to print and retrieve canister logs even in the event of a failure. So before this feature, we only supported logging at the application level, which meant that logs couldn't be retrieved if the canister entered some failure state. So now that it's available at the system level, this should help a lot with debugging and also tightening developer feedback loops. Next slide, please. So we have a couple more that will be coming soon. One is canister state snapshots. And with this feature, you'll be able to roll back your canister to a previous checkpoint in time. And this should help with things like disaster recovery, incident management. And then next up is enhanced orthogonal persistence. And this is a feature that I'm really excited about. And it will allow your canister state to essentially live forever without ever needing to interact with stable memory directly. So it's a very nice feature. We're very excited about it. And it's only available in the Toko. Next slide, please. So there's plenty of good stuff coming. Here's a link to the feedback board. If you visit the feedback board, you can vote for your favorite topics or topics that you want to see us prioritize. You can also add your own. So please stop by, take a look, and then see you all next month. Thank you.
Thanks a lot. Nice to see a constant flow in improvements to developers' lives. Always appreciate it. And with that, we already come to the feature section, which is today actually quite packed with many very exciting things. And let's directly start off with Stefan, who is going to tell us about the new storage layer rollout.
Hello, everybody. I'm Stefan from the message routing team at DFINITY. I want to share some results of the rollout of the new storage layer. So this has been rolling out over the last few weeks. So now we have some real-world data to share. So what this is it's a performance improvement, particularly about the part of the replica code where we write the canister states to the disk. At a point of the code that we call checkpointing. It's also part of the upcoming Stellarator milestone, which contains, among others, the goal to increase the supported state size. So the reason why we are improving checkpointing are a couple apart from the increased state size. It's also that we noticed that it is noticeable from the end user when checkpointing is slow, something we want to improve with because it should be invisible. But also the new storage layer in particular, it's a stepping stone to future improvements that should improve performance even more. Now, what we did on a more technical level is we changed the file format of how we store canister states on the disk. And this file format in turn affects when and how we write, copy, or read data. So the problem with checkpoints is that it's slow. So when you send an update call to the IC, what happens is we put it into a block with other update calls. And our goal is to do 1.3 blocks per second, something we call the finalization rate. And this relatively high finalization rate is important for the responsiveness of the IC. If you send an update call, you want to get the response back within 2 seconds or so. And high 1.3 blocks per second kind of allows us that. If it was much lower, you would have to wait until the next block finally comes around so that your message could get executed so that you could get a response. But even more so than that you want a high block rate, you also want a consistent block rate. Because if you have an inconsistent block rate, sometimes it's quick, sometimes it's slow, and it results in a very weird user experience. And checkpointing is a kind of a problem here because we do this checkpointing step where we write canister state to disk every 6 to 8 minutes. And checkpoints are not quick. The worst case that we currently see on mainnet is around 25 seconds, but we have even seen more in the past. And what that means is that there is no block for 25 seconds. So if you send your update call just before checkpointing starts, you'll wait half a minute for your answer. And from the user, right? You didn't do anything different because 5 minutes ago it was quick and now suddenly it's slow. Furthermore, this checkpointing time, one function of it is the state size, which is why it's related to the state size limit. And our goal overall is to really make checkpointing invisible. And an important step is this new storage layer, which mainly breaks this dependency between the state size and checkpointing. So here are a few numbers of like different subnets and their checkpointing times. So every subnet is different set of canisters, different workload, different state size, and so on. So the first two examples are like two subnets which are kind of the middle of the road subnets. They have like checkpointing time around 7 seconds. The bottom two are kind of the bad cases. EQ6EN is the 25 seconds worst case that I quoted earlier. The Bitcoin subnet is another one that is quite bad with its 20 seconds. And with the new storage layer, this is how it looks like now. So the middle of the road ones got from like 7-ish seconds to 4 seconds. The EQ6EN got from 25 to 17. And the Bitcoin one is where we saw the biggest improvement. It went from like 20 seconds to half a second. So basically not noticeable anymore. Here is the same thing as a graph. So this is a screenshot from our internal dashboards. What you can see here is the checkpointing time on the Bitcoin subnet. The x-axis is time, right? The y-axis is the checkpointing time, and the red line in the middle is when we upgraded the replica. And as you can see, it went from 20 seconds to way lower than 1 second, with the occasional blip up, but even these blips are like to 1 to 2 seconds. You can also see it in the block rate. This is an example of one of these middle of the road subnets. You can see before the update, you can see a block rate that sometimes reaches 1.3 blocks per second, but every 6 to 8 minutes, it kind of dips because it's some kind of hiccup, which is exactly checkpointing. And after the update, these hiccups, they're not gone, but they are much less noticeable. So this new storage layer, right? It's been rolling out over the last few weeks, and the last subnet that's supposed to get upgraded, which is the NNS, is scheduled to be done so on Monday. And the result is the checkpointing times are better. They're better on all subnets. Not all subnets got the same amount of improvement, but all of them got better. And the result of that for the end user is hopefully that it feels less surprising and more consistent when interacting with the IC. It's also a step for future improvements. We have lots of ideas of how to improve it further. So more improvements will be coming to checkpointing time and other parts of the code. And it should allow us, it's one of the main blockers to increase the state size limit further. We are targeting 1 terabyte plus as part of the upcoming Stellarator milestone. That's it from me.
Thanks a lot. That is really very nice to see. I guess I'm excited for 2 reasons for this feature, because first of all, obviously the short-term improvements that are now kind of giving benefits to all the users, but also kind of the long-term implications of this make me sleep a lot better, because now we also kind of can answer much better to scalability challenges and so on. So really great work. And with that, over to an update on boundary nodes.
Yeah, hi everyone, this is Rüdiger, and I'm from the boundary node team. So as you might have seen with the release of the new roadmap, the boundary nodes also got their milestone like everyone else, and it's called Solenoid. And today I want to update you on what that milestone consists of. So it's mostly what you see in this figure here. It's the new decentralized boundary node architecture. And I want to tell you where we currently stand with that. But before we get into that, let's quickly look back on what actually has kept the team busy for a good part of this year. As many of you might remember, at the beginning of the year, there were several occasions at which the boundary nodes reached their capacity limits and their performance degraded. And unfortunately, it didn't degrade gracefully. So this led the team to temporarily switch gears, and we started focusing mostly on two things: improving the performance of the existing boundary nodes and hardening them. And we have done quite a lot of work all over the boundary node. And here I just want to give you a quick glimpse of the improvements we have done on the example of the query throughput. So I took different releases and just measured the query throughput. Next, please. So as a baseline, I took a release from December. That's kind of, let's say, the boundary node as it has been running for quite some time. And it's the boundary node from before any of the improvements. And I measured the query throughput, which I try to depict with this gray box. Next, please. And then as a first kind of improvement, a round of improvement, we started going all over the boundary nodes, streamlining, refactoring, whatever we could. This included, for example, logging improvements, which used quite some CPU before, enhancements in caching, but also, let's say, security enhancements by hardening the firewall, introducing some limits. And as you can see, these improvements all over the place led to an increase in throughput by about 25%. But then we took on another piece. So next, please. And that was eliminating all the NJS, so the JavaScript modules from Nginx. So for a long time, we have been relying on some modules just because Nginx doesn't support interfacing with the IC directly, and we had to add this functionality somehow. And back in the day, this was done with these modules. But we quickly realized that those have a huge impact on performance. So we started eliminating them one by one, which meant rewriting their functionality, and it paid off. So in comparison to the previous release, we got another 55% increase in the throughput. And overall, we managed to improve the query throughput by almost 2x. The boundary node actually consists of more endpoints like update calls and also the HTTP endpoints. So some of the improvements only affect certain endpoints. For example, the caching enhancements mostly affect the HTTP endpoints, where other improvements affect everything. Yeah, so that was a quick view. And now let's get back to the milestone and the new architecture. Next, please. I will just quickly summarize what the milestone is about or what the architecture looks like, and then tell you where we stand. And if you want to know more, I put the QR code in the bottom corner. So this is a forum thread that summarizes everything and where we try to regularly post updates with the current status. So today, the boundary node consists internally of two parts. The blue part, the API boundary node, which routes the API calls to the right subnet and replica. So if you do query or update calls, you will hit this part of the boundary node. And then the purple part, the HTTP gateway, translates the HTTP request from the browser into API calls and back. So only thanks to the HTTP gateway, actually, you can directly access a smart contract, so the canisters on the IC, from your browser. Next, please. And the new architecture, put in very simple terms, just splits the boundary node into two separate entities, so in the API boundary node and the HTTP gateway. So the API boundary nodes will be fully NNS managed, whereas the HTTP gateways can be run by anyone. Now, it's a bit more complex than just kind of ripping out those pieces and spinning them up on different machines. As I mentioned before, we've been relying quite heavily on Nginx with some modules, and we just realized it doesn't fit our purpose. So we decided to build two new services: IC boundary in the API boundary node and IC gateway in the HTTP gateway. So where do we stand today? Next slide, please. With the API boundary nodes, we're actually almost done. So the core service, IC boundary, has been running in the existing boundary nodes for about 6 months. And it also helped us do many of those performance improvements because we could just shift functionality that was in those JavaScript modules directly to IC boundary. The integration into the NNS and the integration to GuestOS have been done, and now we're really just on the final touches, and it's a bit the 80-20. Many small things left that take some time. But really within the next couple of weeks, you can expect to see a proposal to turn the first node into an API boundary node. So watch out for that and vote on it. And next, the full milestone will not be achieved with the API boundary node, but there's 2 more ingredients necessary. So it's the discovery library, which helps clients directly talk to API boundary nodes. So find them and then route the requests there. And there we're actually almost done with the code, and we'll be integrating it into Agent RS such that it's easy for developers to use. And the other part is, of course, the HTTP gateway. There we made quite good progress with the IC gateway. And we're planning to do a similar rollout as we did with IC boundary. So before kind of deploying the fully fledged HTTP gateway, we'll integrate it in today's boundary node to gain some experience and then gradually move to the full HTTP gateway. And now before I conclude, I would just like to thank everyone involved. I'm really just a spokesperson here, and the real work was done by Igor, Nikolai, and Or from the boundary node team. And also big thanks to many other teams that helped or got to help us on this endeavor. So this is mostly NNS, consensus, message routing, and the release team. And with that, back to you, David.
Thanks a lot, Rudy. Really impressive improvements, and also exciting to see what's still gonna come. So really nice to hear. And with that, let's move over to the next feature. Again, a very exciting one, namely WebAssembly SIMD.
Yeah, thanks a lot, SIMD, probably, yeah. Hello, everyone. I'm Andre from the runtime team, and today I'll be talking about WebAssembly SIMD on the internet computer. Our goal is to improve the performance of computation-heavy smart contracts. Why we are doing this? Of course, the decentralized AI is the main driver for this feature, but SIMD can also improve the existing smart contracts. How we are doing this? We've enabled deterministic WebAssembly SIMD. Now, SIMD brings enough speed to enable AI inference directly within queries. In some cases, there is no need anymore to deterministically slice the long execution. This effectively brings Web 2-like speeds for some AI workflows. But first, let's rewind a bit. On the next slide, please. Let's see what SIMD is. SIMD stands for Single Instruction Multiple Data. A single instruction can operate on multiple data elements at once. The Internet Computer Protocol already supports the basic set of WebAssembly instructions. Now, WebAssembly SIMD adds even more instructions. For most basic instructions, there is a corresponding SIMD alternative, which operate on vectors. And on the next slide, please, there is an example of floating point addition. Imagine we need to add like 4 pairs of numbers. Using basic instructions, we can add numbers pair by pair. Each instruction operates over a single 32-bit floating point value. So we need to execute 4 basic instructions in total. The same instruction can be achieved, the same result can be achieved with just single SIMD instruction. It operates over a vector of SIMD of 4 numbers, and adds them in parallel. In this example, basically, there are no dependencies between the operations, so it can be done in parallel. Unfortunately, it's not always the case. Now let's talk about how to use SIMD in your project. Yeah, thank you. Forget tupils. WebAssembly SIMD offers 3 choices. On the left, we have the blue pill, By default, all canisters continue to run seamlessly with the same runtime cost and performance. In the middle, we have the green pill. Here we need to recompile the project with WebAssembly SIMD enabled. Depending on the algorithms and libraries, this might be enough to improve the performance with barely any effort. And finally, on the right, there is the red pill. Here we manually rewrite some core application functionality using WebAssembly SIMD intrinsics. This option offers the best performance. However, it comes with a high effort required to manually rewrite core algorithms. We have a SIMD example. This example covers all three options listed here, but today we will focus on the middle option to see if just recompiling with SIMD enabled can save us some instructions. On the next slide, please. We have two Rust functions, multiply and matrices. Matrix multiplication is the core operation for many algorithms, including AI inference. In both cases, we call the same library function with identical matrices to multiply. The only difference between these two functions is the annotation at the very top. The WebAssembly SIMD instructions are disabled by default, so the function on the left, called optimized, uses just basic WebAssembly instructions. In contrast, the function on the right, called auto-vectorized, explicitly enables WebAssembly SIMD. This gives the compiler an opportunity to optimize the matrix multiplication loops. At the end, both functions return the instruction counter, so we can compare the number of instructions used in each case. As we can see, the optimize function on the left takes roughly 168 million instructions. And by the way, it's called optimize because it's not a naive matrix multiplication. This is optimized multiplication. It uses tiles and packed matrices to improve the efficiency. But those optimization details are beyond the scope of this presentation. So if you are interested, there'll be a link to this example at the end. Okay, now let's look at the right. Seems in this case, the Rust compiler was smart enough to auto-vectorize the multiplication. It took just 13 million instructions. And as we can see, the same code, it's happening even in the same canister, same compiler and identical input data. By just simply enabling WebAssembly SIMD, we can significantly improve some workloads. Of course, please take this result with a grain of salt. Your experience may vary. Rust compiler optimizations are limited and often Rust struggles to optimize complex functions. Sometimes it struggles to optimize even simple functions. Yeah, so yeah, just be careful. That's why basically the third option, the red pill with SIMD intrinsics is there. Basically, it's the only guaranteed way of getting the improvements. But the green pill is definitely worth trying. Yeah. On the last slide, please. The WebAssembly SIMD instructions are generally available. And here is the QR code with a link to the SIMD example. If you are curious to know how many instructions a naive matrix multiplication takes or a super optimized multiplication with SIMD intrinsics, please check out the example. If you want to explore this new feature in your project, start with the green pill. Try recompiling your application and use libraries with SIMD support. There are already libraries with built-in WebAssembly SIMD support, for example, GPEG manipulation library. There are libraries DFINITY is contributing the WebAssembly SIMD support to. For example, the SIMD support is coming to the AI inference library, Sonos Tract. Yeah, so just try it out. Yeah, and yeah, hopefully it will be, you will be happy. Okay, if you have any question, ask them on the forum. As always, huge thanks to everybody involved. Thanks a lot, folks. We did it together. And yeah, back to you, David.
Thanks a lot. Really great to see this extension of the WASM instruction set, and looking forward to how people are going to leverage it to build more performant apps. So thanks a lot for this presentation. Really enjoyed it. And with that, over to Manu, who is going to talk about the ckERC20 project.
Yeah, thanks, David. Hi, everybody. So I'm going to try and talk a little bit about the ckERC20 project. So do a recap of what we set out to do and where we stand, and hopefully what's coming next. So the ckERC20 project is about creating these chain key twin tokens, like we have with ckBTC and ckETH and now ckUSDC, for ERC20 tokens on Ethereum. So ERC20 is the token standard on Ethereum, and there's many interesting tokens on Ethereum that follow the standard. So it will be interesting to bring them over. And the CK tokens, as you know, are like these twins of other tokens that are native to the IC in the sense that they follow the ICRC token standard. So you can transact them very quickly with low fees. And we think this is interesting because this would bring more tradable assets into ICP, which can give ICP DeFi a boost. It brings trusted stable coins into the ICP ecosystem, which is very important for DeFi. I think in the crypto space, you see that like the majority of the trading volume is actually with stable coins. And it would also kind of strengthen the position of ICP as a hub between blockchains if there's different tokens from different blockchains that you can all trade on ICP. And how are we doing this? Well, we already have ckETH and the ckETH minter that uses chain key signatures to hold native ETH and then facilitate conversions between native ETH and ckETH. And this project extends the responsibilities of the ckETH minter to now do the same for some ERC20 tokens. That's kind of the goal that we set out to do a while ago. And we've made a lot of progress here. Let me see if I can control the slides. Yes. Because now this code is functional, and we now have the first such token, which is ckUSDC. So this was last week there was an NNS proposal which proposed to upgrade things to add support for the ckUSDC, which was adopted. So now we've had this token for a week, and this allows you to transfer, I guess, a USD stablecoin in like seconds for just 1 cent transaction fee. So that's very exciting. So I'll first tell you a little bit about all the cool things you can now do with this, and then talk about the future. So there's many things you can already do with ckUSDC today. Because it follows the ICRC token standards, so it's the standards of ICP, it means that essentially all wallets immediately support ckUSDC. So that's very convenient. So you can hold it in many places. The NNS frontend tab works a little bit differently in the sense that you cannot add your own tokens, but it was upgraded to also support this token. So you can also hold it there if you want. And not only the wallets immediately supported this, also OpenChat very quickly added support for ckUSDC, which means you can now send ckUSD around in chat messages, which is kind of cool. And all the DEXs on the Internet computer also were quick to jump on ckUSDC. So you can now buy some ckUSDC if you want on ICP Swap, Helix, Sonic, ICDEX. Or if you already have a lot of it, you can help provide liquidity. Of course, these things just started, so the liquidity is not super deep yet. But that's an interesting thing you can do. What's noteworthy is that last week also a different stablecoin launched on the IC, which is this BTEL from the Thaler DAO, which means that now also we have the first stable trading pair on ICP that we didn't have before. I think that in particular is an interesting place to provide liquidity because you don't suffer the risk of this so-called impermanent loss. So I'm curious to see how that will continue. And alternatively, if you have USDC on Ethereum, then you can now choose to bring it in and make it into ckUSDC, which you can now use on the internet computer very easily and fast. And there's different ways of doing that. Oisy is a multi-chain wallet that DFINITY is building, so you can hold IC assets there and Ethereum assets. So if you send your Ethereum or your USDC there, that just with the click of a button, you can convert it into the CK, the twin token. So that's super convenient. If you have USDC in some other Ethereum wallets, then there's two other convenient ways to do it. There's IC Lite from the IC Lighthouse team and ICP Swap that both provide front ends for conversions as well. So they can just directly connect to your wallet and convert tokens from there in one go. So this is very cool. I'm very happy that the community all chose to jump on this so quickly. I think many of things were already there on day one. So that's super exciting, and I think that's very important to collaboratively make this a success. Then, if you want to follow the progress and see how ckUSDC is doing, and you don't have Kyle around to give you a nice overview of the metrics, then you can look at the internetcomputer.org dashboard as well. So this added support for ckUSDC, so you can see a lot of interesting things there, like all the transactions that are happening, the canister IDs, the supply, so how much ckUSDC exists, and the account view. And I just heard that there's more things coming, so this is very interesting to follow. I think we're currently at 250,000 in ckUSDC, and the number is quickly rising, so that's very nice. And if you want to dive even deeper into the details, there's the ckETH minter that exposes a dashboard with essentially all of its internal state. So if you really want to know how it works and see like the Ethereum transaction IDs, which correspond to some mints of ckUSDC, you can find all of that there. And I think that brings me to the next point. This is just a reminder. So ckUSDC is not mixing funds. You cannot hide your traces by taking USDC and making it into ckUSDC or vice versa. It's all intentionally very transparent. And this minter dashboard gives you all the information you might want. So then I want to talk a little bit about the future. And so what we already have today is a ckETH minter, which facilitates the conversion between Ethereum and ckETH. And now what's new is a canister called the Ledger Suite Orchestrator, which is directly under NNS control. And this Ledger Suite Orchestrator is supposed to facilitate the addition of new ERC20 tokens to become CK tokens as well. And it does so by taking care of all the individual ledgers, because we now think we might end up with many ledgers in total. And because it's under NNS control, you can now submit an NNS proposal that says, I would like to add a new ERC20 token, for example, DAI. And if the NNS, if we as a community accept this proposal, then it would create new tokens, a ledger and an index canister, and it would inform the ckETH minter that a new ERC20 token was added, and now the ckETH minter should also follow that token and look for deposits, essentially. So when it looks at the state of Ethereum, it looks only for a set of tokens, but now the newly added token would be added to the list. So this is how it works. So I guess the takeaway is we can now add CK versions of ERC20 tokens with NNS proposals. And this means that now it's up to the NNS and us as a community to decide which tokens we add next. And so I guess we are starting the discussion here at DFINITY internally and what people think here. Some ideas, maybe we can even add a token every week. I think that I hope that soon the discussion starts on which tokens people would find most interesting, and then hopefully we can grow the set of CK tokens further. And have many more things to trade in the near future. Here's a link to the forum where the discussion is happening. So thanks for your attention, and I'm happy to take questions.
Thanks a lot. Really cool overview, and it was really cool to see ckUSDC launching last week. And yeah, also looking forward to discussions and new twins or CK twins launching on the IC soon. With that, over to demos. And the first demo is by OpenChat about verified credentials in OpenChat.
Hi, thank you. I'm going to talk about verified credential integration in OpenChat pretty briefly. I'm going to show you a quick demo of what this looks like inside OpenChat. So if I can just share screen, we'll just dive straight into the demo, I think. There we go. So I think everyone probably knows what verified credentials are. They're a way for, an app may wish to verify some property that a user has, some credential that they hold. But we want to kind of decouple the two ends of the equation. So we don't want the app to have to verify the credential themselves. We don't want the user to have to disclose any more details than they need to about the credential to the app. And so, can everyone see my screen, by the way? My OpenChat screen?
I can see it, yeah.
Yeah, great. So this is of interest to us in OpenChat because it's a great way for us to control access to groups and communities. We may wish to say that a particular group is only open to people who have proved that they are human or something, or have proved that they're a certain age or whatever. In this case, we're demonstrating the control of access to a group to people who've attended this particular conference, okay? Because that's a credential issuer that DFINITY have set up, and it's a good opportunity for us to demo the capability. So it would start by having a particular channel within OpenChat, as I have here, this welcome channel. If I go into the settings for this channel, you can look at the access control, choose an access gate, and we have this new option here for verified credential. And this is where we would enter the details of our credential. I'm not sure why it's got hold of that credential. Just refresh. So OpenChat doesn't know anything about these credential issuers at all. You just simply enter the details of one that you know provides the credential that you want. We will probably also provide some kind of canned credential issuers in the future. It depends whether the issuer is kind of generically useful, such as proof of humanity or something like that. But in the case of this conference attendance credential, it's pretty niche, so it would probably be just entered that sort of thing manually. So we enter the canister ID, we enter the issuer origin, we give it a name, whatever. That's just so that we can recognize it. And we give it a credential type, which in this case is attendance, and they may or may not have arguments, so we can add extra arguments here as well. In this case, we need to give the event name, not with a Q on the end though, and that would be -24. So we update that channel, and then that's protected that channel with that access gate. Assuming it's going to save. Okay, so that's saved now. And if we look in the channel details, we can see it's describing the access gate here in the channel properties. So that's it from the point of view of the controller of the channel. We go over to another user. So this would be the users who wishes to join the channel. So the first thing they would have to do is obtain the credential. Okay, so how that's done is really dependent on the credential issuer. In this case, DFINITY have set up this website here where a user can sign in with their internet identity, the same internet identity that they're going to be using with OpenChat, and they can use that as a way of kind of declaring that they have this credential. So I'll go ahead and do that. Sign in with internet identity here. And then I'm told that I've got the credential now. In the live version, we would then click on this group button here, and that would be the channel that was protected by the credential. But I'm not in the live environment here. I'm in a test environment, so I have set up this channel over here, which is the one we just protected with the credential. We can see from this user's point of view, it's got this padlock on it, and that tells us that only users who can supply this conference attendance credential will be allowed to join. So if I try to join, it's going to stop me and say, I need to verify that I've got this credential first. So I click verify. It's going to trigger the verified credential flow within internet identity. And there it is telling me exactly what's being asked for. This is the credential that's being asked for, and it's going to be supplied to the relying party, which is OpenChat in this case. And if I want to proceed, I press present credential to sign in again using the same internet identity. And assuming I have the credential, which I should have, it's going to pass that back to OpenChat. So OpenChat is now doing its normal, calling its normal endpoint to join the channel, but it's passing with it the credential that I supplied. The back end of OpenChat will verify that credential, and then I'm in. So that it's as simple as that, really. And you can see there's loads of applications that we can think of for this really easily. A big one for us will be proof of humanity. It's going to be really helpful for people who wish to do things like airdrops in their OpenChat channels, but they don't want to be just throwing prizes at bots. But I'm guessing the community will come up with whatever credentials they think they need, and they can write their own issuers, and OpenChat doesn't need to know anything about those implementations. So I think that's it really from me.
Thanks a lot. Really excited to see attribute-based credentials coming to life within OpenChat. Really great demo. Okay, and with that, over to the final demo, which is a community demo by Omnity.
So, well, hi everyone. I'm Ting from Omnity Network. So, that's first. So today I'm going to walk you through the whole Omnity cross-chain process. Right. So before we get started, I would like to invite all of you to join our Telegram group for the Red Envelope game. And at the end of this presentation, we will be airdropping our room token. Hope you get rich in the group. So yeah, don't miss out. I have put the QR code on each slide, so you can take your time to join the group while I'm presenting the project. Right. Actually, I have prepared a recording demo to showcase that utilize our cross-chain implementation. But before we start watching the video, I would like to briefly introduce our concept and the current state of the project. So Omnity is a cross-chain project that leverage the IBC standard and ICP technology and provide a safe, fast, and cheap cross-chain experience. And what makes us stand out between all these cross-chain projects is we aim to be 100% on-chain and facilitate millions of cross-chain transactions per day without sacrificing any safety, speed, and cost. And our team have been exploring the interoperability domain for 5 years and dedicating ourselves to optimize the cross-chain experience. And Omnity design is based on IBC protocol standard and ICP technology stack. And this is the high-level overview of Omnity design. In the middle, we use Hug as the central point to handle the relationship between the settlement chain and the execution chain. And then we have GAVE for the settlement transaction logic and part of the verification, and both for the execution change transaction logic too. And on each changed end, we set up a smart contract to handle the token minting as well. We can dive into the detail with one of our use case implementation, which is the bridge from the BTC network to ICP network. And this is our current application architecture. So as you can see in the diagram, the Bitcoin adapter and the Bitcoin canister have already been launched on the IC mainnet and support the ckBTC application. What makes it possible is the unit subnet structure of IC, where a dedicating Bitcoin subnet with each node run a Bitcoin adapter daemons, and it's independently connect with the Bitcoin P2P network. Once the subnet nodes reach the consensus on the new Bitcoin block, the block will feed to the Bitcoin canister, which maintain a whole UTXO set. A Bitcoin canister can be viewed as the indexer for BTC assets, but additional indexers are needed to support more types of assets. Omnity plan to deploy a Bitcoin token indexer parallel to the Bitcoin canister to support rooms and the other tokens. So on the application side, those are the layer 2 from different networks. To bridge token to Bitcoin network, verifying the cross-chain message on the target chain is usually the most computational intensive and costly part of the trusted cross-chain process. The Omnity's both smart contract sign the cross-chain message, and the target chain authenticate them by checking his signature. And as the previous diagram show, the Omnity hub is the connection between the execution change and the Bitcoin gate, which is connected to the Bitcoin canister. Well, with that being said, let's jump into our demo, and I will be showing you how to bridge room token from the BTC network to the ICC network with on the Omnity website with OKX wallet and the Plus wallet extension. Hope you guys see it okay. I have fast forward the process. So this is BTC to ICP. Yeah, 12 block confirmation, which is about 2 hours. And this is ICP to BTC. Okay, and that's it. I think back to the demo. So yeah, that's all for the Omnity mainnet demonstration. And coming next, I would like to present you the other dApps that is built based on the Omnity functionality, the Omnity Red Envelope, a rooms token snatching game on Telegram. So if you heard of Chinese New Year, you might know that we will give away some red envelope token, red envelope for wish of good luck and fortune. And if you are using WeChat, then you might come across the red envelope snatching game. Actually, the same idea here. All you need to do is just make a clip on this UI on Telegram when you see it, and you will just get some free Hope You Get Rich rooms token. And actually, what I would like you to do is I will set let's see, how many have you guys joined the group yet? Let me see. Oh, cool. There's at least 12 member. That's good enough. So what I'm going to do right now is it's easier to. I'm going to send a red envelope with 10 shares. So yeah, first come, first serve. Good luck. Let's see. It's going to take 2 or 3 seconds. And here you can choose the group. And there you go. So all you need to do is just make a clip here on Snatch. And then you will just, so the whole process is quite self-explanatory. I guess you got the idea so far? Okay, good. So yeah, back to the slide. Right. So at this point, you might be wondering, like, how do you track your wallet balance since you already have some room token? We have the front end support on the on Telegram, just like this. All you need to do is just add the red box from the Omnity official group, and this is the group name. And yeah, and then once you have added this red box, you can just type */ and then the red envelope dashboard will show up and everything will be quite self-explanatory. And actually the reason, what I want to point out is the reason we start this red envelope game is we would like to bring the Web3 technology to Web2 social environment by having the user to interact with our Omnity cross-chain implementation. And this red envelope as an implementation of ICP Telegram agents is open source right now. Open source now, so please check it out here. And yeah, so Omnity next stage will be supporting change like EVM, Solana, and Cosmo. So yeah, that's all for me. I have ran through the slide because I ran out of time maybe. But thank you for listening, and please keep eyes out for our close medium, which is here. So yeah. Thank you.
Thanks a lot. Very nice demo. Too bad I couldn't join the interactive part as the speaker here, but really enjoyed watching it. And with that, let me quickly switch to the final slide. So thanks a lot, everybody, for attending. I hope you also enjoyed the kind of nice updates on all kinds of improvements across the stack, and of course also the demos. And with that, see you next time.